Imagine drifting silently through the outer dark, past the orbit of every planet you've ever been taught to fear. No sunlight to speak of, no warmth. Just a deep, endless blue growing larger in front of you, calm and still, like something asleep at the edge of existence. You'd expect nothing to be happening down there. You'd expect silence. You would be wrong. Because hidden beneath that peaceful blue surface is one of the most violent, unpredictable, and quietly terrifying worlds ever discovered. A planet where the winds move faster than anything else in the solar system, where the atmosphere hides storms the size of entire continents, and where something buried deep inside is generating energy nobody can fully explain. This is Neptune, and by the end of this video, you'll understand why scientists still don't fully understand it. If you're fascinated by the mysteries of the universe and want more documentaries like this, subscribe to Beyond Cosmos. Now, let's begin. Neptune sits roughly 4.5 billion kilometers from the Sun. That's about 30 times farther away than Earth. At that distance, sunlight arrives nearly 900 times weaker than it does here. If you stood on Neptune at what should be high noon, the sky wouldn't look like daylight at all. It would look like permanent twilight, a dim glow instead of a blazing sun. Scientists expected that to mean something simple: less sunlight, less energy, a quiet atmosphere, a dead world essentially frozen in stillness, with barely enough power to stir a breeze. Instead, they found the opposite. Neptune has the fastest winds ever recorded anywhere in the solar system. We're talking about speeds over 2,000 kilometers per hour. To put that in perspective, the most powerful hurricanes on Earth top out somewhere between 250 and 400 kilometers per hour, and those storms can level cities. Neptune's winds move nearly 9 times faster than that. They're even stronger than the storms on Jupiter, a planet that sits far closer to the Sun and receives dramatically more solar energy. Here's where it gets strange. The Sun barely touches Neptune. So where is all that energy coming from? That question leads to one of the biggest unsolved mysteries in planetary science. Neptune radiates about 2.5 times more heat into space than it actually receives from the Sun. Somewhere inside this distant, frozen-looking world, something is generating its own internal energy, constantly, without any need for sunlight at all. Scientists have theories. Maybe it's leftover heat from the planet's violent formation, energy trapped since the birth of the solar system. Maybe it's slow gravitational contraction, the planet very gradually compressing under its own weight and releasing warmth as it does. Maybe there are deeper internal processes we haven't identified yet. But here's the part that keeps researchers up at night. Uranus, a planet almost identical in size and composition, sitting right next door, does not do this. It doesn't produce that same surplus of internal heat. Same size, similar makeup, completely different behavior. Nobody has a complete answer for why. So the terrifying part isn't that Neptune is cold. It's that something hidden deep inside its core is quietly generating power, right now, and we don't fully know why. That mystery becomes even more unsettling once you try to imagine what it would actually be like to descend into Neptune's atmosphere. There is no surface to land on. Not a rocky plain, not an ocean, nothing solid at all. If you fell toward Neptune, you wouldn't hit ground. You would simply keep falling. First through clouds of frozen methane, the gas that gives the planet its haunting blue color. Then deeper, into thickening layers of hydrogen and helium. The pressure would build with every kilometer, the temperature climbing alongside it, until the atmosphere around you stopped behaving like gas altogether and became something closer to a superheated, high-pressure fluid. A strange, slushy mixture of water and ammonia ices under conditions no human material could survive. Somewhere far beneath all of that, scientists believe there's likely a rocky core. But no spacecraft, no probe, nothing built by human hands could ever get there intact. Long before reaching it, the crushing pressure and extreme heat would destroy any vessel completely. There is nowhere to stand on Neptune, no horizon to walk toward, just an endless, silent descent into something heavier and hotter than anything we've built to withstand. And in that crushing environment, something else may be happening, something that sounds almost too strange to be real. Deep within Neptune's interior, immense pressure may be transforming carbon into diamonds. Methane, one of the main components of Neptune's atmosphere, contains carbon atoms. Laboratory experiments recreating Neptune-like pressure and heat have shown that under those exact conditions, carbon can separate out and crystallize. If that process happens inside Neptune the way researchers suspect, those diamonds wouldn't just form once. They could keep sinking deeper into the planet again and again, creating something scientists have nicknamed diamond rain. It's important to be honest here. This isn't something we've directly observed happening inside Neptune. It's a hypothesis, strongly supported by lab experiments, but not something anyone has actually witnessed. Still, think about what that means. The most violent storms on Earth produce rain made of water. Neptune, if this theory holds true, may be producing rain made of gemstones, falling endlessly through a world no human will ever set foot on. As if an internal furnace and a possible rain of diamonds weren't strange enough, Neptune's magnetic field breaks the rules too. On most planets, including Earth, the magnetic field lines up reasonably close to the planet's rotational axis and passes roughly through its center. Neptune's magnetic field does neither. It's tilted by about 47 degrees, and it's dramatically offset from the planet's actual center. As Neptune rotates, its magnetic poles don't stay put the way Earth's do. They sweep and wobble through space in a way that looks almost chaotic from the outside. Scientists believe the field is generated by electrically conducting fluids churning somewhere in Neptune's interior. But the exact structure creating this bizarre, lopsided magnetic behavior remains uncertain. Even the invisible architecture of this planet refuses to follow the pattern. For decades, almost everything we know about Neptune traces back to a single moment. On August 25, 1989, a spacecraft called Voyager 2 became the only human-made object ever to fly past this planet. It wasn't there long, just a brief, fleeting encounter before continuing on its way out of the solar system forever. But in that short window, it captured something remarkable: a massive dark storm system, roughly the size of Earth itself, later named the Great Dark Spot. Then years later, when Hubble Space Telescope turned its eye back toward Neptune, the Great Dark Spot was simply gone, vanished, and in its place, new dark storms had already begun forming elsewhere on the planet. Try to sit with that for a second. Imagine discovering a hurricane larger than our entire planet, then coming back a few years later to find it's completely disappeared, replaced by something new. Neptune's weather doesn't just move fast, it transforms on a timescale scientists never anticipated, evolving in ways that continue to catch researchers off guard. And Neptune's chaos doesn't stop at its atmosphere. It extends to the objects orbiting it, especially its largest moon, Triton. Triton doesn't behave like a normal moon. Most large moons orbit in the same direction their planet rotates. Triton orbits backward, moving in the opposite direction of Neptune's spin. That single detail is one of the strongest pieces of evidence that Triton wasn't born alongside Neptune at all. Scientists believe it likely originated far away in the icy Kuiper Belt, before being captured by Neptune's gravity and locked into permanent, unnatural orbit. Voyager 2 also spotted something else remarkable on Triton's surface: nitrogen geysers, blasting icy material more than 8 kilometers into the thin atmosphere. This happens on a moon with a surface temperature of roughly minus 235 degrees Celsius, making it one of the coldest known large bodies in the entire solar system. But Triton's story doesn't end peacefully. Over immense timescales spanning millions of years, Triton is slowly spiraling closer to Neptune. Eventually, it's expected to cross what's known as the Roche limit, the point where Neptune's gravity becomes strong enough to tear the moon apart. When that happens, Triton could be destroyed entirely, its remains possibly forming a brilliant new ring system around the planet that captured it in the first place. Neptune didn't create this moon, it captured it, and someday it may destroy it too. Speaking of rings, most people don't even realize Neptune has them. They're faint, easy to miss, nothing like the dazzling rings around Saturn. But within them are strange clumped formations called ring arcs, dense clusters of material that, according to the physics of orbital mechanics, should have spread out evenly around the planet over time. They haven't. Scientists believe a small moon named Galatea uses its gravity to help hold these clumps together, But exactly how long that stability can last remains an active area of research. Even Neptune's rings refuse to behave the way physics first suggested they should. And that brings us to something worth sitting with. Nearly everything you've just learned, the supersonic winds, the internal heat, the possible diamond rain, the tilted magnetic field, the vanishing storms, Triton's slow doom, the strange ring arcs, comes from one brief flyby in 1989, supplemented by decades of distant observation through Hubble, James Webb, and ground-based telescopes. No orbiter has ever circled Neptune. No lander has ever touched its clouds. No atmospheric probe has ever been sent to measure what's really happening beneath that deceptively calm blue surface. For one of the most extreme and mysterious planets in our solar system, our data remains remarkably thin. We've only seen the surface of what Neptune actually is. And maybe that's the real reason Neptune unsettles us. It isn't loud about its secrets. It doesn't announce its violence. From a distance, it looks like exactly what physics predicted: a cold, quiet, forgotten world at the edge of the sun's reach. But underneath that stillness is a planet that generates its own heat, hides storms larger than continents, may rain diamonds into its depths, and holds a moon that time itself is slowly pulling toward destruction. Neptune isn't frightening because it's dangerous. It's frightening because, more than a century after its discovery, it still refuses to fully explain itself. Every answer we find seems to open a new question underneath it, like peeling back layers of a world that was never meant to be fully understood from 4.5 billion kilometers away. Somewhere out there, at the very edge of what we've explored, a planet is still generating heat with no clear source, still hiding storms that vanish without warning, still holding a magnetic field that bends the rules we thought were universal, and we've only ever looked at it once. Maybe that's the real lesson hidden in the ice and wind of Neptune. That distance doesn't mean stillness. That silence doesn't mean nothing is happening. And that even in the coldest, darkest corners of our own solar system, there are forces at work we haven't even begun to fully understand. If you enjoyed this journey beyond our solar system, subscribe to Beyond Cosmos for more cinematic documentaries exploring the greatest mysteries of space. Thanks for watching, and I'll see you in the next one.